Right, so now we come to the fourth part of the video for today's asynchronous lecture, and basically we have covered we have covered all the learning outcomes that I want to share with you today, which are to find the eigenvalues and eigenvectors of a matrix. Okay, so the remaining what we have is actually just to solve the examples that we have here. Okay, so we're done with A, right, where we have lambda equals to -1. We have found the eigenvectors for lambda equals to -1, and I leave it to you to find the eigenvectors for lambda equals to -2. Alright, so now let's proceed to B. For B, we also have found its lambda before, right, in example 2, where lambda is equals to 0 and another one is 5. Alright, so now let's straight away proceed to the step on how to find the lambda, the eigenvector for each of the lambda here. So we'll begin with lambda equals to 0. Okay, so remember dia punya step tu A minus lambda identity matrix kan, times with x equals to 0. So maknanya sekarang ni saya nak straightforward terus. Kita punya A adalah 1 kan, so maknanya 1 tolak lambda, 2 tolak kosong, because lambda I will give to you, okay, lambda kosong kosong lambda, right? And then here 2 and then 4 minus lambda, kan? This is this one times with x. And then this case, since lambda ni sama dengan kosong, so we get back the same thing. 1, 2, 2, 4, because it's times with 1 tolak kosong kat sini dan 4 tolak kosong kat sini. Then x ni, matrix ni, we consider x1, x2, right, equals to 0, 0. So here what we will have is, so from here we will have x1 plus with 2x2 equals to 0. And the second equation, yang ni 2 darab dengan ni, 2x1 plus with 4x2 equals to 0. Then this one, kalau you factor 2 out, nampak tak, you will get the same thing as the first equation, 2x2 sama dengan kosong. So again kita let one thing that I want to highlight here, kenapa kita tak boleh selesaikan je persamaan ni, x1 plus 2x2 equals to 0, 2x1 plus with 4x2 equals to 0. You buat persamaan serentak kan, x1 sama dengan negative 2x2. You see what happen kalau you substitute negative 2x2 inside this, inside x1 kat sini, you akan dapat kosong. You won't able to solve this biasanya kalau this is the eigenvalues. And remember, x cannot be equals to 0. Okay, x cannot be equals to 0. So to be safe, just let x1 to be equals to any value. Nampak tak kat sini? We have the equation x1 plus 2x2 equals to 0. So up to you. You nak let x1 equals to apa? Okay, katakanlah kat sini saya let x1 equals to 2. Okay, let me let x1 equals to 2 here. Okay, I masukkan x1 equals to 2 here. So masukkan ke dalam ni, saya akan dapat 2 plus 2 x2 equals to 0. So what will be the value of x2 that will make this thing equals to 0? Okay, apa value? You boleh kira pun kan, tercongak macam ni pun boleh. We give us x2 equals to -1. Nampak? Okay, there you go. Kita boleh dapat jawapan x1 equals to 2, x1 equals to 2, and then x2 equals to -1. Okay. Alright. Okay, one possible answer that I have now is our matrix X is x1 equals to 2, x2 equals to -1. Alright, so it's time for us to prove. Macam tadi juga. AX equals to lambda X. So my A is 1, 2, 4 darab dengan X. What I get for my X is 2, -1. And for this one, my lambda here is 0 and X is 2, -1. Obviously, answer kat sini akan dapat 0, 0 on your right hand side. Left ni, dapat tak? 2 tolak 2, 0. 4, 2 darab dengan 2 kat sini, 4 tolak 4, 0. So, it's proven left hand side equals to right hand side. Okay. So, macam tadi, saya let x1 equals to 2, x2 equals to -1. Kalau I tak suka, I boleh je pilih x1 equals to -2. It's not wrong. Kalau saya pilih x1 equals to -2, then what should be my x2 class? Okay, if x1 equals to 2, ni x1 sama dengan, x1 equals to -2, then my x1, my x1 equals to -2, then my x2 will equals to, apa value of x2 that will make this thing equals to 0, given x1 equals to -2. Of course, x2 is equals to 1. So, maknanya, another possible solution is, another possible solution is -2, 1. Okay. Alright, so we're done with lambda equals to 0. Then you may try again on your own for lambda equals to 5. Okay, for lambda equals to 5. I want you to give yourself a try and I can give you answer. Okay, if you okay, for lambda equals to 5, one of the possible answer is, okay, x1 is equals to 1, x2 is equals to 2. Okay, matrix X, this one. This is the answer. You may try on your own. Okay, yang ni tak payah submit pun tak apalah. Tapi if you want to submit, it's fine with me. Yang penting yang tadi ni, yang lambda equals to -2, you need to submit as classwork submission. Fun question. Yang ni tak nak submit pun tak apa. But if you want to include again dalam you punya submission, is fine. It's good sebenarnya kalau you masukkan sekali. It's for your own good kan. You boleh check. Saya dah bagi jawapan yang ni. X equals to 1 and 2. 2 or 4, -1, 2 pun boleh jadi your solution. Make sure you prove untuk soalan ni dalam your solution, make sure you prove. Okay, now let's proceed to the next example. Okay, now let's proceed to example A. We have matrix A, -5, 2, 2, -2. Okay, so untuk find first the eigenvalues, okay, what we got to do is we have to put in this form A minus lambda, I lambda or lambda I sama je. So we put it directly. Okay, saya letak 5 minus lambda. We are to find the determinant kan. Ni determinant macam ni. 5 minus lambda, 2, 2, -2 minus lambda. Kenapa saya buat macam ni? If you still couldn't figure out why, please tengok balik video saya dalam part 2 if I'm not mistaken. Part 2, part 2. Okay, so to solve this is supposed to be equals to 0 kan. So to solve the determinant, kita cross darab silang. So we're going to have 5 minus with lambda, -2 minus lambda, minus with 4 equals to 0. That's it, very simple. So then we have minus, ni darab masuk, -10 minus with 5 lambda plus 2 lambda plus lambda square minus 4 equals to 0, right? Oops, careful class. I just noticed I made a mistake here where I tertinggal negatif kat depan ni. Okay, -5 minus lambda. 2, 2, 2 negatif. Benda macam ni lah kadang-kadang kita manusia kan, instan yang lemah. Cewa. Okay, so -5 darab dengan -2. So, jadi patutnya positif lah kat sini. Okay, plus 10. And then -5 darab dengan negatif lambda. So, sepatutnya ni positif juga. Positif 5 lambda. Okay, plus 2 lambda plus 2 plus lambda square minus 4 equals to 0. Alright, Then 10 minus with 4, you will get 6 plus 7 lambda plus with lambda square equals to 0. Dan daripada sini, kita boleh factor. We will get lambda plus 1, lambda plus 6 equals to 0. There you go. We are able now to find the lambda, where lambda is equals to -1 and -6. Alright, so we're done to find the finding the eigenvalues for matrix A, part A. We get lambda equals to -1 and lambda equals to -6. Now let's proceed to find the eigenvectors. Okay, jawapan tadi kita ada lambda equals to -1 dan juga -6. So now let's consider first for lambda equals to -1. So if lambda equals to -1, ingat macam mana kita buat? Okay, we consider -5 minus with lambda, so minus 1. Okay, and then kat sini, okay, and here 2, and then 2 minus bukan kat sini 2 ni tak ada apa-apa kan, 2 just leave it, and then minus 2, this is the one that support the diagonal part. Ingat, the diagonal part yang kita tolak dengan lambda, so minus 1. Alright, okay, and then this is our x1, x2 equals to 0, 0. Right, so here what we have is -4 to -1. Okay, x1, x2, 0, 0. So what we give is, it will give you -4x1 plus 2x2 equals to 0 for the first equation. Nah, mana dapat ni? Ni -4 darab dengan x1 tambah dengan 2 darab x2. And another one is 2x1 minus x2 equals to 0. Alright, so saya rasa yang ni senang dah lah. Actually you can factor, nampak tak yang ni? Kalau you factor, you bring out apa? 2 kan? -2, you will get 2x1 minus x2. Sama je equation tu. Yang first dengan yang second. So now, what you want to let as your x? Let x equals to, x1. Katakanlah, nak senang kita let x1 equals to 1. So if you let x1 equals to 1, then x2 akan bagi awak equals to apa? Ni kalau masukkan 1 ke dalam x1, so dia 2 darab 1, untuk jadi kosong, x2 kenalah 2. Right? So your matrix X for this, for lambda equals to -1, give you matrix X, x1 equals to 1, x2 equals to 2. Kalau you tak nak nombor ni, there are some other answers. Okay, -1, -2 boleh, -2, 4 pun boleh. Macam tu lah. Alright, then you can prove AX equals to lambda X. Yang ni I nak tinggal kat you pun, we can, okay lah, saya tunjuklah satu yang ni. -5 to 2 darab dengan kita punya X kat sini, 1, 2. Right, equals to, kita punya lambda is -1 darab dengan 1, 2. So kalau kita darab, -1 darab dengan 1, -1 darab dengan 2, you will get -1, -2 kat sini kan. Then this one check, dapat tak sama? -5 tambah 4, yes, you will get -1 kat sini. And then yang ni 2 tolak 4, definitely -2 kan, darab masuk ni. Ni yang ni. So samalah dengan yang ni, proven. Alright class. Okay. And then untuk samalah juga sebenarnya step dia ni untuk -6 pun saya rasa saya tak nak buat lah. Untuk -6 you can try on your own. Can you? Okay, you can try on your own. For lambda equals to -6, I'll straight away give you one of the possible answer. Okay, for lambda equals to -6, one of the possible answer, it can be matrix X can be X equals to 2, -1. Ni one of the possible answer. You boleh try, work out on your own and dapat tak? Okay, one of the possible eigenvector for lambda equals to -6 untuk matrix A ni adalah 2, -1. Nak tahu jawapan you betul ke tak? You prove AX equals to lambda X. Okay, prove this one. If you get it correct, left hand side equals to right hand side, then you will all fine. Alright, okay. Okay, so untuk B, untuk B ni sebenarnya same step, everything is all the same as how we solve for A. So that's why untuk B ni, I leave it to you to try to find the eigenvalues and eigenvectors as well. This one as your classwork submission. Yang ni yang saya sebut dalam class overview baru ni. To make sure that you really engage with me and all of you are able to achieve the learning outcome for today to find the eigenvalues and eigenvectors. Show to me that you are able to solve example 4B. Okay, so there are 2 questions for you. Not 2, okay lah, satu soalan yang ni and part of the question that you need to find the eigenvector for lambda equals to for lambda equals to -2 kan. Yang ni you need to solve also. So there are 2 questions. Yang ni pendek je. You just need to find the eigenvector for lambda equals to -2. Alamak, tiba-tiba je masuk pergi semua benda ni. Alright. Okay, class. Sorry, ada technical error tadi. Tiba-tiba je my tablet ni pergi entah mana-mana. Alright, so that's it. Okay, we're done with today's lecture. And I leave it to you with 2 questions to submit by 11:59 tonight. Alright. So, submission will be open dekat you punya Google Classroom. Alright everyone, thank you. See you in our next class through Google Meet. Assalamualaikum warahmatullahi taala wabarakatuh and good day. Bye-bye.